Hello, we're going to do some chain rule examples, and we're going to do double prime, y double prime of this right here, and we're going to do first y prime of the tangent of x, and the derivative of the tangent of x is secant squared x, which you remember is basically equal to the secant of x squared. So these two things are equivalent to one another. Now if we do y double prime, make that look a little bit better, double prime of this, we have to apply the chain rule. So this would become 2 times the secant of x, and then it would be to the 2 minus 1 power. Now I'll write this. 2 minus 1 is of course 1, so we don't need to write that. It's just to the first power, times the derivative of what's inside here. So the derivative of the secant of x is the secant x tangent x. And then if we simplify this, this is going to become, yellow is my final answer, 2 secant squared x tangent x. And all these are multiplied together. So because there are 2 of them, that's why it becomes secant squared of x. Alright, so let's go to a little bit beefier problem. Okay, so here's our next example. And this is a review problem. You should know how to do this. I'm going to pause this, you do it, and I'll be right back. Alright, now, let's figure out how to do this problem. This is a definite chain rule example. Because you have this outer function here, take stuff inside taken to the negative 2 power. So we're going to apply the power rule and make this negative 2 times all of this inside here. And then this would be to the negative 2 minus 1 power, which would be negative 3. And then we're going to multiply that by the derivative, and we could write the notation out. Suppose it wouldn't hurt to do that. We could, we're going to multiply all this by the derivative of what's inside. So we have to figure out what is inside of this thing. All right, so I'm going to rewrite this, because that is not going to change. I'm just going to be messing with this on this side now. Times the derivative of x. Now, because this is a sum here of 2 different things, we're just going to take each one. Okay, now the derivative of x is 1, and the derivative of this is of course, I could write this, I probably should write this as x to the 1/2 power here. And let's do this. As much as I don't want to write this one more time, I'm going to. Times 1 plus, and this would be 1/2 x to the 1/2 minus 1 power. Now 1/2 minus 1 is the same as 1/2 minus 2 over 2, which is negative 1/2. And so this, I suppose you could leave it like this, but most of the time they're going to put it back in radical form. So x, and chain rule problems is just a whole bunch of recopying stuff. This could be probably better written as 1 plus 1 over 2 square root of x, like that. And that would be a final answer for that. Now, if you're like, that's easy, let's look at another one. Okay, now we have a new kind of chain rule problem that is kind of a compound chain rule thing. So you'll have to do the chain rule 2 or 3 times on this. So I'm going to pause this. I want you to try this one. Alright, so let's do this. First, I'm going to use light blue for the first step here. So if we're doing y prime, basic power rule, I'm going to take the 3, put it down front, carefully recopy everything. And this would be 3 minus 1, or to the 2nd power. And then we're going to do the derivative of what's inside this thing. So I'm not going to skip any steps on this. Okay? So we're going to take the derivative of all of that. And so now we'll do green for step 2. All right, so this gets recopied. Now, the derivative of 1 is, of course, 0, and I am going to leave that off. Okay, so it's 0 plus. And this right here, the cosine squared 7x, that's the same as this now. Let's make sure we get this straight. That's the same thing as that. So this is going to become 2 cosine 7x, like so. And then we got to multiply that by the derivative of the function cosine of this function here. Let me outline this in white. Of this right here. Okay, now I'm going to get that, erase that. But it's going to be times the derivative of cosine 7x. Like that. So now we got to do y prime equals 3 1 plus cosine squared 7x squared, just recopying. I can copy the green now. And I'm going to take the derivative of the white thing here. So cosine 7x, the derivative of cosine of x, is negative sine of 7x. And then I have to take the derivative of, this is almost silly to write, but 7x. So now my final step, which I'll make in bright purple or pink or whatever color that is, y prime is 3 times 1 plus the cosine squared 7x squared. I did put extra parentheses around that. That doesn't matter really. And then 2 cosine 7x times negative sine 7x times the derivative of 7x, which is just times 7. So now we look at all the coefficients of this thing. So I have a negative 1 here. All right, now check this out. Don't blink here. I got a negative 1 here. Let me circle all these in orange. I got a 7. I got a negative 1 coefficient. I have a 2. And I have a 3 out front here. This 1 is not the same because that's 1 plus. That's all wrapped up in that thing. But I can now take 7, negative 1, 2, and 3 and multiply them together. And that would be negative 42 times 1 plus cosine squared 7x to the second times cosine 7x times sine 7x, final answer. And we'll just double check that to make sure we nailed that. And that is correct. So that's a great example of a multi-link chain rule problem. Have a good one.